Hi, today I'm going to respond to um, the quantitative problems that I received. I know someone actually tried to email me a copy of this. This is this is a it's a long-term mathematics. I believe yes. It's uh, long-term quantitative is quantitative, yes, quantitative reasoning, and this is for grade 5. This is for basic, for grade 5. And luckily enough, I have the copy. I I I, I use it too. I know and I can understand the problems that people have. Well, I will go straight to the page that was scanned and sent to me. Well, this is I can say that this is page 44 and page 45 of this book. Um, like I say, it's quantitative. It's a long-term quantitative reasoning. Well, I have come across some of the problems in this book, and I noticed that it's not only them, most of the quantitative reasoning problems that I come across them, they do not really um, make them understandable to learners. Unlike mathematics, that a learner can can be able to learn of his or her own. In quantitative, most of the problems it seems to be impossible for learners, which means they must have a teacher or a professional uh, to be able to guide them. Um, where I think it will be a good idea if they do something about it for people that write these quantitative textbooks, or we should write our own. you know. So looking at this problem, according to the email that I have, they don't know how they got other numbers, but what they have here is that I think when they wrote this thing, they say it's equals to 5, you know. And then these ones are left like this without any explanation, but these are the samples. Okay, so let's see if I have this. I don't know how we can get this 5, but I know that 3 plus 5 can give me 5. Yes, it's like that. But then I have another problem that is similar to this, where I have 6 and I have 4 to be equal to 20, right? To be equal to 20 in the same, um, I think it's in the same book. Yeah, it's in the same book. So you see, with 6 plus, uh, whether it's plus, where there's a symbol there that looks like the one we use in quantum physics, you know. So let's say, okay, I want to get 5 here. What can I do? If I say 3 plus 2, I can get 5. But how about this problem? This is 6. If I say 6 plus 4, it won't give me 20. It won't. So I need to find a way that works for the first and the second and to the rest of the problem. So here I can easily say, I can square this one. If I say 3 square minus 2 square, I will definitely have 5 because 3 square is 9 and then minus 4 square is 4. So if I say 9 minus 4, it will be equals to 5. And then I apply the same method here and it works. If I say 6 square, this is 6 square minus 4 square, it will be equals to 20. So which means 6 squared minus 4 squared is 20. It works well because 36 minus 16 will be 20. So this is perfectly done. And I come here in a similar manner. I have 15, 2, I have 6, then there is a 46 in the box. I don't even know how. They don't even explain, but they say this is a sample that does not even have any explanation. So how do you expect learners to learn? Or you don't encourage studies in, in quantitative. So let's see what we can do here. What I did in this problem is that I tried to look at how they are arranged. I tried to look at the next ones that I see in this book. You know, I try to add them all together and then multiply by 2, which give me the same value in the box. And all of them work that way. For example, in this first one here, I say 2 plus 6, 2 plus 6, then plus this 15, then times 2. Okay, so if I do this, I am going to have 46. Okay, I add all the numbers to that, multiply them by 2, and then it give me 46. Then I come here the same, 7 plus 8 plus 5, you know, then times 2 also give me 40. And then it is a method that works for all the problems that I have in there, you know. So it's really a quantitative problem. It's a reasoning problem. There's also another one with same diagram that has 3, 4, and then there's a 16 in the middle with a 1 down. Now, the same thing, I can still do the same. If I say 3 plus 4 plus 1, then times 2. Is same. I am still going to have the same uh, answer, which will be 16 in the box. That the 16 is in the box. So for quantitative reasoning, there are many ways, but the best way is to find a method that works for all the problems. We need to work with division, subtraction, addition, you know, and multiplication. Is These are the key when it comes to quantitative reasoning. I will bring more videos. You will see I will bring more solutions for these quantitative reasonings so that people who have similar issues, they will be able to study them of their own and then explore more solutions. You will have more ideas on how to teach your students on quantitative without a problem. Meanwhile, you can contact me. You can send any of the problems to me. Anyone that you see you find it difficult, you can send it to me and I can help you explain. But subscribe and follow my channels to be able to see, because I'm going to be solving more of these quantitative problems for both teachers and students to be able to understand some of the problems inside of these books. There are a lot of books on quantitative reasoning, a lot of books, a lot, but the problem is to understand how to work these problems.